Where does space end? NASA went to find out, and tonight we take a deeper dive to see what they found. Our first edge is surprisingly close to home. It's called the heliopause, a vast invisible border marking the true edge of our solar system. For billions of years our sun has exhaled a constant stream of charged particles, a stellar gale known as the solar wind. This wind travels outward at 1,000,000 miles per hour, carving out a colossal magnetic bubble in the interstellar medium. This bubble, the heliosphere, is our cosmic shield. It's the domain of the sun. But what happens when that solar breath finally runs out of steam? It collides with the cold, dense wind of the galaxy itself. That collision zone is the heliopause. For decades, it was pure theory. Then two tiny emissaries from Earth, launched in the 1970s, went to find it. In 2012, after a journey of 35 years, Voyager 1 felt it, then slipped through. The data it sent back across billions of miles was unmistakable. Suddenly, the solar particles it had been measuring for decades vanished, replaced by a surge of high-energy cosmic rays from the galaxy beyond. The magnetic field shifted its orientation. Space itself got quieter, the familiar hum of the sun's influence replaced by the whisper of the interstellar void. Out there, the sun's protection thins like fog at dawn. Voyager 2 followed it across the boundary years later, confirming the readings. The probes pinged back a message that was as profound as it was simple. You have left the yard. We had, officially, become an interstellar species. But our solar system is just one household in a city of billions of stars. To find the next edge, we need to look deeper and further back in time. This edge isn't a place, but an epoch, bottled in ancient light. In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky near the Big Dipper that seemed utterly, profoundly empty. For 10 consecutive days, Hubble stared its electronic eye, gathering every last photon. What it revealed wasn't emptiness, it was a cosmic treasure chest, crammed with thousands of galaxies, the Hubble Deep Field, thousands of island universes, each containing billions of stars of its own, all packed into a sliver of the sky no bigger than a grain of sand held at arm's length. We were looking back in time, seeing galaxies as they were billions of years ago. The light from the most distant among them had traveled for so long that it left before the Earth had even formed. We had discovered a new kind of edge, the edge of deep time, but Hubble's vision had its limits. The very expansion of the universe works against us. As space itself stretches, it also stretches the light traveling through it, shifting it towards the red end of the spectrum. This is called redshift. For the very first, most distant galaxies, their light has been stretched so much it's no longer visible light at all, but infrared, heat. To see it, we needed a new kind of eye, the James Webb Space Telescope. Webb pushed that edge harder, peering through the cosmic dust to catch the faint infrared glow of infant galaxies. It found them, shining in the darkness when the universe was less than 1 billion years old, some perhaps just a few 100 million. Their light left before our own galaxy had even settled into its spiral shape, stretched into deep infrared by 13 billion years of cosmic expansion, like a siren fading down an endless street. Yet even Webb cannot see the absolute beginning. If you look past every star, past every galaxy, no matter which direction you point your telescope, you eventually hit a wall. Not a wall of matter, but a wall of light. A faint, pervasive, and almost perfectly uniform glow that fills the entire cosmos. This is the cosmic microwave background, or CMB. It is the biggest edge of all because it's not an edge of distance, it's the edge of origin. This is the afterglow of the Big Bang itself. For the first 380,000 years, the universe was an impossibly hot, dense, opaque fog of plasma. Light was trapped, endlessly scattering off free electrons. But as the universe expanded and cooled, protons and electrons finally combined to form the first atoms. In that instant, the universe became transparent. The light that had been trapped was set free, and it has been traveling across the cosmos ever since. Today, that primordial light has cooled to a mere whisper, just 2.7 degrees above absolute zero. When we map it, we get a baby picture of everything, and that picture holds a secret. It isn't perfectly smooth. Satellites like COBE, WMAP, and Planck have measured minuscule temperature variations, modeled patches that are just one part in 100,000 different. These tiny temperature ripples were the seeds of everything. They correspond to tiny differences in density in the early universe. Over billions of years, gravity went to work on them, amplifying them relentlessly. The slightly denser regions pulled in more and more matter, growing into the first stars, the first galaxies, and eventually the vast, interconnected cosmic web that forms the grand architecture of the modern universe. From almost imperceptible wrinkles in the fabric of creation, everything we see today. But light is not the only messenger from the cosmos. There is another edge, one that hides in the silent language of gravity itself. Albert Einstein predicted it a century ago, that massive, accelerating objects would create ripples in the very fabric of space-time, gravitational waves. For decades they were a phantom, too faint to detect. That changed on September 14, 2015. At two facilities thousands of miles apart, the Laser Interferometer Gravitational Wave Observatory, or LIGO, felt a tremor. It was a signal that had traveled for 1.3 billion years, the echo of two black holes spiraling into each other and merging into one. For a fraction of a second, that collision released more energy than all the stars in the observable universe combined, not as light, but as a pure distortion of reality. LIGO and its European counterpart Virgo heard space-time ring like a bell. No light, just ripples, waves in reality itself. It was a new sense, a new way to perceive the universe. Edges you don't see, only feel. Gravitational waves let us hear the universe's darkest secrets, and some of those secrets create their own, very literal, edges. There's an edge made of pure shadow, the event horizon of a black hole. This is the ultimate boundary of no return, a point in space-time so warped by gravity that once you cross it, no velocity, not even the speed of light, is fast enough to escape. For years, this too was just an idea, a terrifying consequence of Einstein's equations. But how do you take a picture of something that, by definition, emits no light? You take a picture of its silhouette. In an audacious feat of global collaboration, astronomers created the Event Horizon Telescope. They synchronized a network of radio telescopes across the planet, from Hawaii to the South Pole, effectively creating a single virtual dish the size of the Earth itself. They pointed this planet-sized eye at the supermassive black hole at the heart of the galaxy M87, 55 million light-years away. After processing petabytes of data, they unveiled the image. A ring of fire, the glow of superheated gas and light, bent and lensed by a gravity well so profound it has no return address. At its center was not an object, but a void, the shadow of the black hole. We had sketched the edge of infinity. Now zoom all the way back. Take in every edge we've explored. The heliopause, the dawn of galaxies, the afterglow of creation, the ripples of space-time, the shadow of a black hole. They all exist within one final, all-encompassing boundary, the observable universe. This forms a sphere, 93 billion light-years in diameter, with us at the very center. This isn't because we're special, it's simply a consequence of the finite speed of light and the age of the universe. Since the universe is about 13.8 billion years old, we can only see objects whose light has had 13.8 billion years to reach us. Anything beyond that distance lies over our cosmic horizon. Its light hasn't arrived here yet, and because of the accelerating expansion of the universe, driven by dark energy, there are vast regions of space we will see. Galaxies are being carried away from us faster than the speed of light, not moving through space that fast, but space itself is expanding between us and them. Beyond that horizon, more universe almost certainly continues, filled with more galaxies, more stars, more possibilities, unseen, unlit, and forever beyond our reach. It is the ultimate edge, a boundary defined by the limits of light and time itself. So what did NASA and its partners really see at the edge of everything? They saw that there isn't just one edge. There are many stacked like layers of reality. They saw a protective bubble our probes have now outgrown. They saw that a patch of empty sky was in fact a window to the dawn of time. They found the faint, fading afterglow from the moment of creation, and in its texture, the blueprint for the cosmos. They learned to listen to the hum of space-time itself. And they photographed a shadow where light itself cannot escape. Each time we built an instrument capable of reaching what we thought was a final boundary, the universe surprised us. The border moved. The map expanded. The lesson wasn't that there's a final wall waiting for us at the end of it all. The lesson is that edges are not barriers. They are invitations. And tonight, those invitations keep coming. New gravitational wave detectors will listen for the faint, continuous hum from the Big Bang itself. Next-generation telescopes will hunt for the light of the very first stars, the so-called population 3 stars forged from pure hydrogen and helium. And new probes are being designed to sail far beyond the heliopause, not by accident but on purpose, to explore our interstellar neighborhood. It's like standing at a cosmic shoreline watching the tide go out. The farther it recedes, the more of the vast, mysterious seafloor appears. We are explorers, charting that newly revealed territory. The edge of everything is not an end. It's just the place where our current light runs out, and we are still, and always, turning on the lights.